How does one-dimensional conduction compare to multi-dimensional heat transfer? Imagine holding a metal rod and feeling the heat travel from one end to the other. That's a simple example of heat moving through a solid. But how exactly does heat transfer differ when it moves in just one direction versus multiple directions? Let's find out. When heat conduction happens mainly along one line, like in a long, thin rod, it's called one-dimensional conduction. This means the temperature changes mostly along the length of the object, and the sides stay pretty much the same. It's like heat traveling straight down a pipe or through a flat wall. This simplification makes the math easier because you only have to think about heat flow in one direction. Engineers often use this model when dealing with thin walls, long pipes, or flat plates where heat moves from one surface to another with little sideways spread. Now, if heat spreads in more than one direction, it's called multidimensional heat transfer. Think of a complex electronic device or a three-dimensional engine part. Here, heat doesn't just move straight through, it disperses in multiple directions. This makes the math more complicated because you have to consider how heat flows in 2 or 3 directions at the same time. Solving these problems often requires computer simulations because the equations involved are more complex. For simple shapes like cubes or cylinders, you can sometimes find exact solutions, but for irregular shapes, you need numerical methods like finite difference or finite element techniques. The main difference between the two is how complex the math gets. One-dimensional conduction uses simpler equations and assumptions, like uniform temperature across the cross-section. Multidimensional conduction doesn't make those assumptions and captures the real temperature variations in all directions. This makes one-dimensional models great for quick estimates and basic designs, while multidimensional models are better for detailed analysis of complex systems. Applications also differ. One-dimensional conduction works well for things like insulation in walls or pipes where heat mainly moves straight through. Multidimensional conduction is essential when designing electronic devices, engines, or anything with complicated shapes where heat needs to be managed in all directions. Because of these differences, engineers choose the right approach based on the problem's complexity and accuracy needs. In summary, one-dimensional conduction simplifies the problem by focusing on heat flow in just one direction, making calculations easier and faster. Multidimensional heat transfer considers multiple directions, providing a more complete picture but requiring more advanced tools to solve. Both methods are useful, but knowing when to use each helps in designing better systems and understanding how heat moves in the real world.